Welcome to Manifested Publishers.
Hello learners, welcome to our today's lesson. Remember the program is still Manifested Online Lessons. I am your teacher Mwaniki and we are learning chemistry form 2. The topic is still chemical families and patterns in properties. In the previous lesson, we discussed the gradation in size of atom and ion. Gradation in size of atoms and ion, where we were explaining the trend on the size of atom or the atomic radius and the ionic radius, where we said that the atomic radius of alkali metals increases down the group. The atomic radius of alkali metals increases down the group. And the reason we gave is, it is because as you go down the group from lithium, sodium to potassium, that there is an additional energy level occupied by the electrons. And that is why the atomic radius increases down the group. Secondly, the ionic radius, we said it also increases down the group. And ionic radius, we say that this is the radius from the center of the nucleus to the outermost energy level of an ion. This is after loss of electrons, because alkali metals form ions by losing one electron from their outermost energy level. Therefore, the ionic radius also increases down the group, because down the group there is also an additional energy level occupied by the electrons. And the last thing we discussed in that previous lesson was the comparison between atomic and ionic radius. We said that the atomic radius is always larger than the ionic radius. And the reason we gave was, it is because the alkali metals form ions by losing one electron from their outermost energy level. And once they lose that one electron from their outermost energy level, the remaining electrons, the effective nuclear charge increases, and therefore they are pulled much closer to the nucleus. And that's why you find that the ionic radius is smaller compared to the atomic radius. Those are now some of the trends. When you're now told to explain the trend of ionic and atomic radius, then the trend is just the tendency or the inclination on a particular direction. How are they inclined? How is the tendency of the atomic radius down the group, or how is the tendency of ionic radius down the group? In this lesson, we are going to discuss the physical properties of alkali metals. Physical properties of alkali metals. And the physical properties we are going to discuss are, one is the appearance. How do alkali metals appear? Second is the ease of cutting. How is the cutting or the ability of cutting alkali metals? Third is melting and boiling point. Melting and boiling points. Fourth is the electrical conductivity. Electrical conductivity, are they good or bad conductors of both heat and of electricity? Fifth, we have ionization energy. ionization energy. So appearance, ease of cutting, melting and boiling points, electrical conductivity, and ionization energy. Those are the factors or the physical properties or characteristics we are going to discuss of alkali metals. Let's start with the first one, which is appearance. When you talk about the appearance, you see that when these alkali metals are freshly cut, they have a shiny metallic luster when they are freshly cut. So when freshly cut, they have a shiny metallic luster. So when you cut the metal, now the cut surface is shiny, but this shiny surface quickly tarnishes on exposure. So it quickly tarnishes on exposure. So once you cut it, then after some time, it tarnishes because it reacts with the atmospheric oxygen. If it is sodium, then sodium will react with atmospheric oxygen, leading to formation of sodium oxide. But if it's potassium, again, potassium will react with atmospheric oxygen, leading to formation of potassium oxide. So that's how it is. So generally, alkali metals, when freshly cut, they have a shiny metallic luster when they are freshly cut. But this shiny metallic luster quickly tarnishes. Tarnishing means they are oxidized by the atmospheric oxygen, now leading to formation of oxides, and that's why they are not shiny anymore. The second physical property is the ease of cutting. How are alkali metals? Are they easy or are they difficult to cut? So the ease of cutting, you see that the ease of cutting increases the ease of cutting increases down the group. This means that it is easier to cut sodium than lithium. It is easier it is easier to cut sodium than lithium, and it is also easier to cut potassium than sodium. So the ease of cutting increases down the group. The ease of cutting increases down the group. And that's why it is easier to cut sodium than lithium, and it is easier to cut potassium, and it's easier to cut potassium than sodium. And this ease of cutting is because of the forces of attraction holding the atoms of these metals together. The forces of attraction holding the atoms of alkali metals decreases. Or you can say the weakens down the group. The forces of attraction holding the atoms of alkali metals weakens down the group. This means that the forces of attraction holding the atoms of lithium together, they are stronger than the forces of attraction holding the atoms of sodium together. And the forces of attraction holding potassium atoms together are weaker than the forces holding the atoms of sodium together. And that's why the ease of cutting increases. It becomes more easier to cut these metals as you go down the group. And again, remember when you're talking about down the group, you're talking of lithium to sodium to potassium. That is now what you're calling down the group. So it becomes easy to cut as you move down the group. Our third physical property is melting and boiling point. Melting and boiling point. The melting and boiling points of alkali metals, they decrease down the group. Melting and boiling points of alkali metals decrease down the group. And again, this one is also explained using the forces of attraction which are holding the atoms of these metals together. That the forces holding the atoms of these metals together, they weaken as you move down the group. They are more stronger in lithium than potassium. And that is why lithium has a higher melting and boiling point compared to sodium and also potassium. Therefore, they, which are now melting and boiling points, decrease down the group because the forces holding because the forces of attraction holding the atoms of alkali metals weaken down or weaken as you go down the group. So they are stronger, or the strength is more in lithium than sodium, and it is more in sodium compared to potassium. Therefore, the smaller the atom, the stronger forces of attraction holding the atom together. The smaller the atom, the stronger the forces of attraction holding the atoms together. Remember, you are talking about metallic structures, or just a structure. Structure of lithium, structure of sodium, structure of potassium. Therefore, this metal is now made up of so many atoms. Therefore, we are saying that the forces of attraction holding the atoms of lithium, they are stronger than the forces of attraction holding the atoms of sodium together. And these forces of attraction, they are the ones which are determining the melting and boiling point. Therefore, if they are stronger in a certain atom, then it means that there will be high melting and boiling point in that atom compared to the atom where the forces of attraction are weaker. That is about the melting and boiling point. We'll discuss the next physical property, and this is electrical conductivity. Electrical conductivity. Alkali metals are good conductors of electricity. They're good conductors of both heat and electricity. This is because they have delocalized electrons within their structure. So whatever you are calling delocalized electrons, these are the number of these are the electrons in the outermost energy level. That each atom in lithium has one electron in the outermost energy level. Therefore, these electrons, they are always in motion. They are moving throughout the structure of that metallic structure. Therefore, as they move throughout the structure of that metal, then those are what we are calling delocalized, because they are delocalized because they are in continuous movement. That one electron, then that is what is causing these alkali metals to be good conductors of electricity and heat. So they are both conductors of heat and electricity. But because all of them are having one electron in the outermost energy level, lithium, sodium, and potassium, therefore they have the same conductivity. There is no metal which conducts more than the other, because all of them are having one electron in the outermost energy level, and therefore they have the same conductivity. You cannot compare the conductivity, because the conductivity of these alkali metals is just the same, because all of them are having a single electron in the outermost energy level. And that electron is localized. So what is making them to be able to conduct electricity is because of the localized electrons. So have that in mind. The next physical property is ionization energy. They first have to define what ionization energy is. And you see that this is the minimum energy required This is the minimum energy required to remove an electron from the outermost energy level of an atom in gaseous state. The minimum amount of energy required to remove an electron from the outermost energy level of an atom when that atom is in gaseous state. That is what is called ionization energy. And this ionization energy decreases down the group. The ionization energy decreases down the group. Therefore, if you compare the ionization energy, or the energy required to remove one electron in the outermost energy level of lithium, is higher than the amount of energy required to remove one electron from the outermost energy level of sodium. And the same happens in sodium and potassium, that require more energy to remove an electron from the outermost energy level of sodium than potassium. So that is a trend of the ionization energy. And this is caused by the number of energy levels. But the energy levels or the size increase down the group. Hence, nuclear attraction reduces. The nuclear attraction reduces. So by this I mean that lithium with a configuration of 2,1, sodium with a configuration of 2,8,1, and potassium with a configuration of 2,8,8,1. If you look at the sizes, the size of this one is too small, meaning that the strength, we said here that the strength holding the atoms, they are stronger than, for a smaller atom, they are stronger than for a larger atom. Therefore, the same thing is happening here, that the forces of attraction are more in lithium compared to sodium, and they are more in sodium compared to potassium. And therefore, to remove one electron from the outermost energy level of potassium will be so easy compared to removing the one electron from the outermost energy level of sodium. I hope you get that clearly. This is because the strength, like lithium is a small atom. Being a small atom, the strength of the forces holding the atoms of this lithium together, they are more than the forces of attraction holding sodium atom together. And therefore, the ionization energy will be higher in lithium, or you require more energy to remove this one electron from the outermost energy level of lithium than removing one electron from the outermost energy level of potassium. So don't forget that ionization is that minimum energy required to remove an electron from the outermost energy level of an atom when that atom is, or when that atom is in gaseous state. And those are our physical properties of alkali metals. Maybe to go through them once again, there were 5. There's appearance, there's ease of cutting, there's melting and boiling points, there's electrical conductivity, and there is ionization energy. Remember, we have said again that the appearance, they have, when freshly cut, they have a shiny metallic luster. The cut surface is shiny, but this shiny surface, it quickly tarnishes on exposure, because these are reactive metals and they quickly react with atmospheric oxygen, leading to formation of oxides. And that's why the shiny metallic luster disappears. Second, we have discussed the ease of cutting, and you have said that the ease of cutting increases down the group, or becomes easier as you move down the group, because the forces of attraction holding the atoms decrease as you go down the group. So the forces are more stronger in lithium compared to sodium, and more in sodium compared to potassium. And therefore, because cutting involves breaking those forces of attraction, that is why you require more energy, or it is more difficult to cut lithium atom than sodium, and more difficult again for sodium compared to potassium. The next, we talked about the melting and boiling point, and you have said that the melting and boiling point again decreases down the group, And it's because, again, of the same thing that the strength of the forces of attraction weaken. These forces of attraction weaken down the group. And down the group means from lithium, sodium to potassium. If they weaken down the group again, then it means that the melting and boiling points of sodium will be higher than potassium, and the melting and boiling points of lithium will be higher than sodium. The next is electrical conductivity, and you've said that all alkali metals are good conductors of electricity, and the particles enabling them to conduct electricity are called delocalized electrons. And the delocalized electrons, they are the ones you have said, the outermost electrons. This outermost electron, they have one electron in the outermost energy level, all of them. So if they have one electron in the outermost energy level, that one outermost electron moves throughout the structure of these metals, and therefore these are the ones which conduct electricity. Next is the ionization energy, and you've seen that ionization energy is the minimum energy required to remove an electron from the outermost energy level outermost energy level of an atom in gaseous state. And again, you have said that it requires more energy to remove an electron in lithium compared to sodium, and more in sodium compared to potassium. So that brings us to the end of our lesson today. But I will leave you with this assignment, and the assignment is state and explain the trend in the following physical properties of alkali metals. So the properties are appearance, ease of cutting, melting and boiling point, electrical conductivity, lastly, ionization energy. Ionization energy. So state and explain the trend in the following physical properties of alkali metals: appearance, ease of cutting, melting and boiling points, electrical conductivity, and ionization energy. Therefore, ensure that you've done that work before we meet in the next lesson. In the next lesson, we will discuss the chemical properties of alkali metals. Thank you for being part of the lesson. Meet you in the next lesson. Thank you.